Okay, now that we're all set up, we can start looking at actual machine learning tasks. We're going to start simple with supervised learning and linear regression. Now, if you remember, supervised learning is when we have data that is already labeled and we train the algorithm using that data. Once it's trained, it can then predict labels on data it hasn't seen before. For example, in this unit, we're going to use a data set of analytics from the website Mashable, which, if you haven't been there, is a tech and entertainment website with something like 50 million visits a month, so the sample size is pretty substantial. Each one of these records includes information about one article from the Mashable site, including the URL, when it was published, how long the article was, how many keywords it targeted, what day of the week it was, and so on and so on and so on. Each one of these facts about the article is called a feature. We're going to start out with a simplified version of the data that looks like this. As you can see, this data has 4 features: the URL, the title length, article length, and the number of keywords. It also has one label, the number of shares. The difference between a feature and a label is that the feature is measured, while the label is what you're ultimately trying to predict. Ultimately, our goal is to define a mathematical equation that relates the feature to the label so that we can use it to predict unknown labels using just the features. Think of it like a recipe. If you know that you have 12 goats and they eat 24 cups of feed a day plus 3 flakes of hay, if I told you that I was feeding 48 cups of feed a day as well as 6 flakes, could you tell me how many goats I was feeding? Sure you could. Simple algebra. 12 goats equals 24 cups of feed plus 3 flakes of hay. So if we divide both sides by 12, we see that 1 goat is 2 cups of feed and a quarter flake of hay. So you know that if you have 48 cups of feed and 6 flakes of hay, you can predict that you are feeding 24 goats. The key here is in using your data to figure out what the recipe is so that you can make those predictions. In the next module, we're going to look at trend lines and what they have to do with those formulas. In Unit 1, we talked a lot about the slope of a line, and there's a good reason for that. It's because when we're trying to find those formulas, we do it by finding a line that best fits the data that we have. You can think of this line of best fit as the trend line. Let's say we're going to order some paper clips with flat rate shipping. We can plot what the order will cost us on a graph. These points are all on a line, so we can easily draw that line. This makes it really easy to find the formula of the line because we can just take 2 points and find the slope, as in slope equals the rise over the run, which is 14 minus 8 over 3 minus 1, or 6 over 2, or 3. So we have a slope of 3. And then we can find the y-intercept, which remember is where x equals 0, by using the formula y equals mx plus b. So if we take one of those points, 1, 8, we start out with y equals 3x plus b, and then we have 8 equals 3 times 1 plus b, or 8 minus 3 equals b equals 5. So the equation of the line is y equals 3x plus 5. You can think of that slope, the m, as the weight. For example, in this case, for every box of paper clips you put in your shopping cart, it's going to cost you $3. That's the weight of the paper clips. The y-intercept, on the other hand, is the bias. That's the number you're going to pay regardless of how many boxes of paper clips you buy, or in this case, $5. The idea of weights may make a little bit more sense if we look at more than one feature. For example, if we were trying to find the price based on the number of paper clips we're buying and the number of steaks we're buying, we might find that the price increases based on the steaks much more strongly than on the paper clips. In other words, the steaks have more weight. In math terms, this might become price equals the weight of the paper clips times the number of paper clips plus the weight of the steaks times the number of steaks plus the bias, which is the shipping. In this case, we're changing what we call the slope, but don't get confused here. That's all it is. It's just a generalization of y equals mx plus b. Okay, so we started with an example where all of our data points are on the same line. But what if they're not? What if it was more like this? Well, we can still make a line that best fits the data. We just have to work a little harder. So in the next module, we're going to look at cost functions and the graphs they make.
If you're enjoying this video, you'll be glad to know that it's just a small part of a much larger course that can be found on Manning's live video platform. Live video is host to a variety of courses for software developers and engineers, and features helpful tools like our interactive transcript and intuitive integration with our live books. For this course and others, visit livevideo.manning.com.